The Metis Tech Show.
Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
The Metis Tech Show.
So, Chris, you've been talking to me about chicken cutlets. We haven't talked about that before, so you had something you wanted to get off your chest.
Yes. So the chicken cutlet, very elusive, right? And there's a significant difference with the way a traditional chicken cutlet is made versus how, in my opinion, they should be made. So growing up, it was always you just take chicken, you put it in the egg, you scramble the egg, you put it in there, you put it in breadcrumbs, and then you fry it.
Yep.
Right? But there's really a lot from the initial unpackaging of the chicken to before it even gets in the fryer, what really needs to be done.
Okay.
Right? So you take your chicken, you pound it out, tenderize it, and then you have to let it dry out, right? You got to let it dry out. And then in doing that, you really need to concentrate on what are you going to put in these breadcrumbs?
Mm-hmm.
And I feel like everybody, they take the shortcut. They go and you get your Italian breadcrumbs that already have the seasoning in them.
Yeah.
You just, like I said, you throw the chicken in the egg, you throw it in the breadcrumbs, and then you put it on the fryer, which those are the people you kind of want to distance yourself from because they just,
Now,
they don't understand. It's an art.
so you're Italian, so right there, you probably learned from an Italian mother or grandmother, so you have some authority here.
Right. I mean, the proof is in the breadcrumbs and what you're going to do with it. And, you know, if you're really old school, you take your whatever bread you have on the shelf, you can put it in a coffee grinder, you can make your own breadcrumbs, or if you're like me and you have barely enough time in the day to do anything you need, you go home, you're feeding your kids with pitchforks and slingshots, and then you're getting on with the rest of the afternoon. You can, you know, a store-bought plain breadcrumb, I think, is fine.
Mm-hmm.
But then you have to treat it right. You know, for seasoning, I think the key component is, and you talked about it on your last podcast, Paul, is the grated cheese.
Yes.
Right? It is essential.
Yeah.
And it's not like if you're in a rush and you want to buy, I know you were talking about make America great again. You want to grate the cheese.
GRATE.
You didn't get canceled on that one, did
No,
you?
nobody
All right.
complained. I was surprised.
You can do that in a pinch, but what you got to do is you got to buy the block cheese, grate that in there, and heavy on it. Don't go light. Go heavy on it. And then any other seasoning will do. You know, I'm a fan of a little bit of parsley, maybe a little bit of I think it's like the garlic seasoning.
Yeah.
And then if you want to kick it up a little bit of a notch, chicken seasoning.
Mm-hmm.
Or my father-in-law, he introduced me to, I think it's like a Cajun seasoning that he buys it online from Louisiana. It's delicious. I forget the name of it, but sprinkle that in there, and you put it on the fry later or what have you, and you fry it up, and it's perfect.
Yeah.
And that's the other thing too, is you want to make sure the vessel that you're frying these in, there's, you know, you can't overdo it on the oil.
Mm-hmm.
Right. If you have too much, it cooks it uneven. You have to have just the right amounts. You're cooking one side at a time, 3 minutes aside, flip it over. I'm a fan of the extra virgin olive oil.
Mm-hmm.
Yep.
I know some people get, you know, it's a little steep, $30 a gallon or whatever it's going for these days. It's not cheap, but in my eyes, that's the way to go. I
think
like
so
that.
too.
Yeah. That's the only thing I fry in. It's actually funny that you wanted to bring up chicken cutlets because I just moved into an apartment and I wanted to make chicken cutlets, and the only thing I had was like a pre-made bag of Spanish rice, and then I had Italian breadcrumbs and no flour. I did have eggs, so I was trying to figure out like how can I make a chicken cutlet with what I have.
No, don't go there. No.
So what I did have was unflavored protein powder.
Oh my God.
This is horrifying.
So I used that as my flour before my egg wash. And then I seasoned the breadcrumbs, but same thing. It was Italian breadcrumbs, but I put like some cayenne pepper in there, paprika, just to give it more of that, Mexican inspired flavor. It was great.
Well, one other thing the paprika does, I was going to mention it when Chris was talking. The paprika, it helps it golden up a little more when you're frying it. It gives it a little bit of color besides the flavor.
Yeah,
Paprika and turmeric. If you haven't used that, it's delicious. It really, it's like it's an Asian spice. It's kind of like from the ginger root or something like that. But you put that on there and it's fantastic. And actually, my wife will probably kill me that I'm going to talk about this, but in prepping the chicken cutlets before, we take our powder, we keep it in one jar, and then we keep our pancake mix in another jar.
Okay.
To the untrained eye, they look the same, right? So, she's prepping the chicken cutlets. I'm doing whatever I'm doing. And then, we're cooking it, and they tasted good, but they tasted a little off.
Yeah.
And it's like, oh, what did you do with these? I don't know. Lo and behold, she ended up using pancake mix instead of flour to make the chicken cutlets. Yeah. And, it got the job done. I guess when you cover it in Frank's Red Hot or whatever, it kind of masks it a little bit. But, protein powder, I don't know if I would endorse that.
That's horrible. That's just horrifying.
To be honest, you couldn't even tell. It was the weirdest thing.
I don't believe you.
I did it just in a pinch. Well, it's unflavored, so it's just like
it's still not right.
Maybe texture more than flavor it would affect, but I was surprised it didn't make a difference. But what I actually do sometimes, unless you get your oil temperature like perfect, what happens to me a lot when I make cutlets is they'll kind of burn the breading before the chicken's cooked. And so a lot of times what I do is just worry about getting the breading to the right amount of fried, and then I'll throw it in the oven to finish.
Yeah, I've done that.
Just because that way you don't have to worry about overcooking the breading, and if you got the time.
So I mentioned this the last time, but I used my griddle. Typically, I'll take a frying pan and fry them in batches, and then by the end, some of the coating, the breadcrumbs fall off and they get burned. But on the griddle, I cooked them all at once. I don't know how many cutlets I had, maybe a dozen or more. But I'll throw in the olive oil. I agree with you. I only use olive oil. I don't use any other kind of oil. But I mix it with butter. I'll put some butter on there for flavor.
Yep.
And if they're nice and thin, if you pound them, it's okay. But if they got any thickness to them at all, they do tend to burn the bread before it cooks the whole chicken if you can't manage the temperature right.
Yeah.
That's actually a good question. So when you are planning to do chicken cutlets, what are you getting at the grocery store for chicken? Are you getting breast or are you getting them pre-cut in the cutlets?
Honestly, I go with the tenderloins.
Or tenderloins, yeah.
We go tenderloins, pound them out, make sure they're nice and thin. Mm-hmm. Though that's the best kind of meat. And, I try to go with you got the store kind of meat where it's you've got your styrofoam yellow container with a saran wrap on it. You don't know where it's coming from. I try to go with a little bit of a higher end if you can get it.
Yeah.
But yeah, we're a tenderloin kind of family. Okay. And, I've tried it. I've taken the breasts and cut them.
Yeah.
It's a little bit of a different texture to it. A little bit, I think it's a little bit more of a robust texture, if you will. But we're tenderloins. And the oil, you brought up oil. It can be really tricky because if you buy, like we cook a lot, we make a lot of leftovers to last us for the week and everything. And it gets tricky because when you use the oil, you're heating it up. All of the breadcrumbs and everything, they'll fall off, and then the oil will kind of lose its consistency, and the cutlets towards the end, they're going to brown up. They're going to burn a little bit.
Mm-hmm. Yep.
So what I've been doing is I've been kind of alternating. I get two pans going at the same time, and I'll cook one on one on the other. And if I see the oil kind of degrading a little bit or getting filled up with the breadcrumbs, I'll try to let it cool off, dump it, and then start over. Because you really, the last 5 or 6 you try to cook, you want those to come out all right.
Yeah.
You don't want to rush it.
How many kids do you have?
2.
Okay. So you're talking like you have like 7 kids.
No, I mean, it's
keeping a lot of
2 kids and then
pans on the stove.
We'll my wife and I will just eat leftovers chicken, put it on salad or make a sandwich out of it or something for for the week. So we usually try to cook about 3 to 4 pounds a night.
Yeah.
I do that, and then I'll use it for chicken parm, my favorite thing. Chicken parm is when I go to an Italian restaurant, that's my go-to dish. First time there, I'm going to judge this place on its chicken parm.
Same.
That's it.
Same thing.
My wife says, get something different. I go, no, I know my chicken parm, and I'm going to find out if this is good or bad. Because if the chicken parm's bad, everything else is bad. If the chicken parm's good,
it's the litmus test. It's the litmus test.
Yeah. Exactly. Anyway, Welcome, everybody, to the Metis Tech Show. My name is Paul Schaubs. Joining me in studio is Bryn. Bryn, say hi.
Hi.
And our special guest today is Chris Terranova. Chris, tell us what you do.
So I am a mechanical engineer for water products at Mitsubishi.
You work for us.
I do.
And you're here in the Boston area.
Correct.
All right. And today we're going to talk about hydronics, water, how we use water for heating and cooling. It's been used in our industry for since heating and cooling was probably around, right? So it's something, comes to mind. First thing that comes to mind for me is chillers, but we're not really going to talk about chillers. I was a contractor in the Northeast. In the Northeast, there's a lot of boilers, whether they're gas-fired or oil-fired. It's you heat the hot water, you send it to where you want it, whether it's baseboard, whether it's an old radiator that's been converted from steam to hot water, or whether it's a radiant panel or even a hydro air. Right? But we're going to talk about how Metis uses water. So where do we start?
Let's start by talking about our water source outdoor unit or condenser, because that's the one that we've had around for a while. We'll get into some of the newer water products, but at least this is one that we've had. Essentially, it's going to work like any of our other Y series or R2 commercial units, but rather than using air as our heat exchange medium for that refrigerant, we're using water.
All right, so that's a City Multi product, and like you said, instead of having an air-to-air coil, we're just using water.
Yeah.
Chris, does that water have to come from any place in particular?
Closed loop.
A closed loop.
Yes. It cannot be an open loop system where you have an open evaporative cooling tower exposed to the elements, because there's a lot of components in water that makes it kind of hard to deal with, right? So if with this product, with the PQHY, they have a braze plate heat exchanger in them. And the braze plate heat exchanger, we have those in all of our water products. The walls in the heat exchanger are fairly thin. I mean, we're talking 2 to 5 millimeters. So when you have an open cooling tower, you can get all kinds of fun stuff in that, right? I've been on plenty of roofs in Boston. You've got seagulls, you've got debris, any particulate in the air, dust from construction sites nearby. That will all collect itself in the water, and then end up, if you're not protecting your system with a strainer, it could end up plugging the heat exchanger.
Sure.
Right.
Yeah.
So that's why any of the literature, it's going to have your water specifications on it, and then in big bold print, do not use on an open loop.
Right. So what we mean, it's just one closed loop, similar to a baseboard system in a house or a commercial building. It's the same water that keeps going around and around and gets circulated.
Correct.
I've done a lot of geothermal before. There were some geothermals where I'm going to grab water from one well and dump it into another well. But that's not what we're doing. This is a closed loop, so it's the same water. We very seldom are going to introduce any fresh or new water into this.
Right. And you may, over time, as no system is perfect, you could have a small leak. Water is going to need to be replenished. That's why you need a maintenance contract. These systems are not kind of a set it and forget it. You need all kinds of things like inhibitors and what have you, just to make sure you're treating the water appropriately. So it's really it's an art.
Yeah.
Water can go sideways real fast if you're not taking care of it.
It's a City Multi piece of equipment. It's the PQRY or the PQHY.
Yep.
Right. Well, R2 heat recovery.
Yep.
The only difference, or the biggest difference, is that instead of absorbing or rejecting the heat into or from the air, we're just using water.
Right. Now, we're still using refrigerant for our indoor coils. So that's the one thing with the PQRHY is we're still using refrigerant. We have refrigerant coils. We're going to get into some of our newer products where we're actually using water coils for the actual heating and cooling. In this case, we're using that water for the condensing side of that outdoor unit as opposed to using it as the actual heating element.
Same indoor units as a City Multi, a Y series, or an R2 as the air source, right?
Yeah.
So that's that. So I think the next thing that we can touch on is the Heat2O product, the QAHV. So Chris, give us a little bit of a high level of what is the QAHV. We've had a podcast on that. Dwayne Barkley was on for that. He went through how it works, but just give us a high level.
Yeah, so the QAHV is heat pump water heater, right? So now we're getting out of the comfort heating and cooling approach, and we're going towards domestic hot water because they're really, up until very recently, there hasn't really been a solution for electrification and in hot water. I mean, you've got your traditional electric boilers you can use to heat hot water, but now with energy codes becoming more and more strict and gearing towards electrification, heat pumps are being looked at as the solution.
Right.
And with the QHV, we are moving heat from a high source to a low source. And in doing that, we're using a CO2 refrigerant. Okay. And that is specific for the QHV with achieving a very stable leaving water temperature. So there are some heat pumps on the market where in low ambient conditions, they can kind of struggle with maintaining a high leaving water temperature at low ambient conditions. With CO2, we don't have to worry about that, which is fantastic because we're not using supplemental electric heat to boost the water temperature. We're able to maintain that at a steady 176 degree leaving water temperature.
Yeah. Yeah. And with the QHV, like you said, it uses CO2. But in this case, now we're using that outdoor unit is essentially that outdoor coil is our evaporator. Right. What we're actually doing is taking in potable water, right, into that condenser in this case. And we're essentially heating that water right through that condenser. And I actually, when I first started here, it was like a brand new product. So I looked into it, and the twisted spiral gas cooler where you've got these refrigerant lines twisted in this nice tight loop around that water pipe. I mean, the way that it can change that water temperature on a single pass with the outdoor unit. This is a really cool product. And it's designed to run at full capacity. Right. So this is at its most efficient when it's running at 100% capacity. Yep. So that's why with the QHV, it's geared towards commercial because it's making a lot of hot water. It's able to make up for large amounts of storage water, as opposed to something like a boiler where you have a water heater that's a low delta T system. Yeah, it's really only changing that water temperature a couple degrees.
Yeah, you're looking at a high delta T on this. So the colder the entering water temperature and the warmer the leaving water temperature, the more efficient the system's going to be. Right. So we're looking at usually 100 to 120 degree delta T on the water side. So it's a low flow, high lift application.
Yeah.
Now, does this also use a braze plate heat exchanger, or is it something different?
It does. It does. So we've got the braze plate heat exchanger separating the QHV from the potable water loop. And again, it's because of water quality, right? So factory requirements are pretty strict when it comes to water quality here. In the United States, we have hard water. Mm-hmm. It's not the best. Right in the Northeast where we are, it's okay. It's a little bit softer. But when you go towards the central part of the country, I mean, they've got rocks in their water. It's really hard. Yep. So the braze plate heat exchanger, again, braze plate heat exchanger. The second time you've heard it, we have it in the PQ, PQHY, PQRY. We've got one in the QAHV. We're protecting our equipment from that hard water. Right. So the way the braze plate heat exchangers are made and how they work, they are you have stainless steel plates that are essentially fused together there with a copper medium, and they're designed to have a fairly high shear stress and turbulent flow. And when I say shear stress, that's basically the force that the water puts on the plates of the heat exchanger. So high shear stress means you have a lot of movement and a lot of turbulence, which is good because it's keeping minerals from collecting on that heat exchanger. Okay. So it's a way to protect the QAHV from that potable water that could have you've got magnesium, calcium, anything in that water. You're protecting it from what could be in there. Gotcha. It's a lot easier to clean one of those out or swap one of those out than it is to get into the guts of a QAHV.
Right. Now this is basically acting as our primary and secondary loop, that plate heat exchanger, right? Our primary loop being our QAHV, right, and then our secondary loop being what's actually getting fed to those storage tanks.
Correct.
Right. Cool. In those storage tanks, and Dwayne Barkley did a good job explaining those. They're sort of like a battery, because when I think of water heaters, in this area, they're domestic hot water heaters that you would see in somebody's home where they're oil fired or they're gas fired, and those have a quick recovery. But with a heat pump, the recovery is not going to be that quick. That's why we need to store the hot water someplace. So we're heating it, we're heating the water, and we're storing it. So that's why it's important to have a storage tank. And then they've also got the residential heat pump water heaters where you have the compressor and the whole refrigeration system sits on top of the water heater.
Right.
I know a lot of people who've installed those, and what they don't realize is where's it getting the heat from? It's getting the heat from the basement.
Yeah.
It's
Drying
getting the
out,
heat
pretty-
from the basement and drying up making the basement a lot colder, or wherever you have the hot water. In my house, it wouldn't work because I got a closet off the kitchen. The water heater is sitting in there, and that's just going to suck the heat out of the house to heat the hot water. So this is a condensing unit. It's sucking the heat from outside, right? And it goes down. What off the top of your head, Chris? Do you know what the operating temperature is outdoor?
Guaranteed to minus 13 Fahrenheit, and they lock out at around minus 35.
Minus 35. I can't remember the last time it got to minus 35.
Yeah, it's been a while.
Yeah, if it does, I'm moving. That's all I'm saying. Is, although I was in Chicago one time and it was minus 25, and they said it was going to warm up to minus 15, and I'm like, it feels the same.
Yeah.
It feels the same. Minus 15 and minus 25 feel exactly the same. There's no difference.
Yeah.
So I forget where I was going with that, but anyway.
Yeah. On the topic of those hybrid water heaters, when I was in a van, one of the saddest things is you'd go into a basement, they'd have the hybrid water heater, and they just have it on electric. They're not even using the hybrid part of it or the heat pump side of it. They're just using the electric because they're like, it's too finicky. It's just easier to do it this way. It's like a colossal waste of money.
And the other thing I want to make clear for the QHV, it's not something you're going to put in a residential home.
Yeah, you're really looking at, probably around 1,000 to 1,500 gallons of hot water consumption per day. So commercial use really, if you're looking at multifamily, 30 to 40 units, honestly.
Yeah.
Yeah.
So an apartment building, a dorm,
Yeah.
college dorm, something like that.
Yes.
All right. And where else do we use water?
So that's going to be our HVRF, our new hybrid VRF. And this is the one we were talking about earlier. We're using those brazed plate heat exchangers again.
Yep.
And those are refrigerant to water now. We're taking refrigerant in one side, water through the other, and we're actually having indoor coils that are water passing through them as opposed to refrigerant.
So this is more like a chiller.
Yep.
Because now we're just getting the refrigerant, we're conditioning the water, and instead of sending refrigerant out to the indoor units, we're sending heated
Chilled water.
or chilled water.
So one of the things to keep in mind with the HVRF is there are some benefits to having our indoor units being water coils, right? Especially with refrigerant changes coming down the line.
Yeah.
But it's not going to replace our traditional VRF, right?
No. So I think, the biggest thing that taken into account here is this is not a replacement for VRF. It's just another tool in the arsenal to satisfy the job requirements. So like you were saying, with the A2L transition, big focal point is going to be keeping the now slightly flammable A2L refrigerants out of the occupied space.
Right.
Okay, so with HVRF, we're taking hot water and chilled water downstream from the HBC or the branch circuit controller and delivering that to the indoor units. Okay, so with that, if you have a multifamily application, a hotel, dorm room where you have those smaller rooms where refrigerant concentration is going to be an issue, that's all eliminated.
Right.
Right, because you just have flooded hydronics in that room.
Yeah.
I mean, now
Yep.
you could still use VRF for that application, but you're going to have to take into consideration refrigerant mitigation with leak detections and so on and so forth. So it's not the end of it. You can still satisfy it with VRF, but like I said, you're looking at another option.
Yeah. Yep. I mean, there's just a lot more to consider now when it comes to, especially like in a dorm situation where you may have a dorm that's a small space and, total charge on a city multi-system can be over 100 pounds.
Yeah.
And so as a means to mitigate having to deal with, okay, what are we going to do with this 10 by 10 space that could potentially have all the refrigerant leak in this particular room? What are our options? This is where the hybrid VRF comes in. We can use water as our inside of our coils, so we don't have to worry about that in those smaller spaces.
So let me do a quick recap here. We talked about the PQR or the PQHY, which is a water source condensing unit. We're still sending refrigerant to the indoor units, same indoor units we use with the air-to-air heat exchanger. Then the QAHV, it's not the same outdoor unit. It's a different outdoor unit, right? And we're talking about domestic hot water, potable water.
Yep.
We're not talking about heating and cooling. There's no indoor units. Now we have the HVRF. This is still the same outdoor unit.
Yes.
Okay, so it's still the same city multi, so it can be water source or air source.
Yep.
Now we got a BC controller that's different than the one we see on the standard city multi equipment. And so it's the refrigerant and the water, the exchange of heat takes place there. And from there, we're sending water out to the indoor units. Now, the indoor units are different.
You got it.
All right. So there's a lot. This is why you need to contact your Mitsubishi salesperson and keep it all straight.
Yeah, or come to training.
Yeah, come to training. Yeah, we cover all of this.
Because one of the other things, too, to consider with just because you brought up the outdoor units, it's only available on our EP units, so it's not available for hyperheat yet. So that's another thing that, you got to be aware of. And ideally, right, and you could correct me if I'm wrong, but we're trying to keep these designs under 10 tons or 10 tons and below.
Yeah, I mean, there's 10 tons is the sweet spot because you're looking at one outdoor unit, one indoor HBC, and then however many indoor fan coils. So technically we can go up to 14 tons, but now you're looking at multiple indoor HBCs, which can get a little pricey. Right? You've got, and each HBC is a closed system. It's a closed loop. So you need to provide all of your components to fill the system, water treatment for both systems. So if you have one HBC, it's a little bit easier on the wallet. 2 HBCs with a 14-ton system, it's doable. You can do it. It's just gonna, it's gonna be a little bit more pricey. Yeah,
and that would be a requirement on any of our our 144 and 168 units.
Right,
we need those 2 main HBCs.
Correct.
Assuming that's how we're doing our piping. So yeah, it just avoids the need for that second closed loop off of that main HBC.
Yep,
and also startup time. Because that's what I get a lot of contractors when I explain to them that each startup procedure on those main HBCs has to be done separate. And depending on how many heads you have, it can go from anywhere from 2.5 to 6 hours of a startup. When you tell them you need 2 main HBCs and they can't be done together, they're like, I don't want to have to deal with any of that. It's a full day or 2 of startup procedure just to get that thing going. So 10 tons and below, sweet spot because it's a quicker startup and higher efficiency, less cost.
Yeah, but plan accordingly. Plan your labor accordingly. It's all it takes. All right. So let's talk about some of the components that are going to be standard for anytime we're heating or cooling water. Right? There are certain things we have to have. The one thing I remember from hydronics from a boiler system is if there's air is bad because I got a circulator and it's. I think we call them circulator pumps, but I don't think a circulator is really a pump. I think, to me, in my mind, a circulator moves water from one side of it to the other side. So we need that solid column of water in that loop.
Yep.
If there's air is bad. That means nothing's flowing.
Right. Yeah. When I hear circulator, I think of a pressure differential creating machine. So you're you're creating a difference in pressure in a closed loop. When I hear pump, I think it's like an open system.
Right.
Yeah. So yeah, air is obviously when you're installing the system, it's not like you have pre-charge pipe, right? Not like pre-charge refrigerant lines or anything. So the system is going to be empty and you have to fill it. And when you fill it, the air needs to go somewhere, right? So usually the easiest way to do it is you put a manual air vent at the top of your system because when you're filling, you're probably going to try to fill from the bottom of the system, push that air up to the top, and you have to relieve it somehow. So an air vent, it's easy. Slam dunk, put it on the top of your system, crack it when you're filling it, close it when it's done.
Sure.
The second means of air removal is your air separator. Now, your air separator it's not the same as an air vent. Okay. An air vent, you're removing the air that's in the system during your initial fill, but your air separator, you're really targeting microbubbles in the water. Your air separator you want to put on your lowest pressure or your highest temperature. And for that reason is because air it comes out of solution a lot better when the temperature is increased and the pressure is lowest.
Okay.
All water is going to have air in it. Microbubbles, they're invisible. You can't see them until your water is heated up. So when that water is heated up, that's when your air separator, the coalescing media inside of it, it's going to capture those small microbubbles and will relieve them from the top of the air separator.
You're the first guest we've had on here that used the word coalescing. Just saying. Just throwing that in there.
So the way I like to think of that, the way you're describing it anyway, having been in a vent is like your air vent that you talked about in the beginning is like a coin vent, right? Yep. It's open. Yep. You're just allowing somewhere for that air to go. When it starts squirting water, you close it off, whereas your air eliminator is picking up microbubbles throughout the system the entire time it's running.
Correct.
And so, when we used to pipe hydronic systems, where would we normally put an air separator? It was usually right off the top of the boiler,
Yeah, right above the
where the
expansion
water
tank.
was the hottest.
Because they sell the little fitting there. They sell the air eliminators with the expansion tank connection right there. It's right. It's where the water's the hottest.
Yeah.
And the air eliminators on the highest system, and it's either manual or they have some that are automatic.
Yep.
But the thing about hydronics is, for me, it always is, it's not a matter of if it leaks, it's a matter of when. So my rule was, whenever I went into a system, if I had to drain it for whatever reason, I'm replacing all the things, the little things that are likely to leak once you touch them. And that's the air eliminators, a drain valve, little things like that.
Yeah.
And to Chris's point earlier, with water, I think maintenance is even more important with water. Not that it's less important with air, I guess but it's critical, because water can do a lot more things than air can.
Yeah. How often did you replace an expansion tank and also say, I'm going to replace the pressure relief valve, just because that's why you noticed it was off, it was dripping. The chances of it reseating are so low, you're like, let's just replace
It'd be
both.
a boiler drain, because the most expensive part of a repair is the time it takes to drain and then fill and purge the water. So if the water is drained already and I'm replacing an expansion tank, why not the pressure relief? Why not a little boiler drain?
Yeah.
But the little things that have been there for years, that once you touch them, you got a boiler that's been there for 30 years, and you touch that drain, the chances of it closing up pretty tight again are going to be pretty slim.
Yeah.
So
Well, that's
put
the
in a
thing
drain.
is, the worst thing is when you do replace that expansion tank and you go, I'm not going to replace the high vent or the pressure relief valve. And then as soon as the system starts to build pressure, you get drips.
Yeah.
You
You do
drain
it's
it down
much,
again,
much cheaper to do it once. So what else do we have? You talked about the air vents. We just mentioned expansion tank. What's the reason for an expansion tank?
Well, the expansion tank is needed because water it's virtually incompressible. So when you're filling a closed loop system, you always want to fill it so there's air removed from the system, and then you want to put a slight positive pressure on the system to make sure air stays out. Usually it's about 5 psi or so. You're filling it with a water temperature, city water temperature, 40 to 50 degrees, and then you're heating that water up to a heating set point for, depending on what the system is, could be 140 degrees, could be 180 degrees for some older boilers. That water needs somewhere to go. Like I said, it's incompressible. So the expansion of that water needs to collect somewhere, hence your expansion tank. And then you just mentioned about replacing expansion tanks. Your expansion tank has a membrane in it. The smaller residential styles, it's a butyl rubber diaphragm in it that will constantly expand and contract depending on the temperature of the water. And over time, that's going to eventually fail. It's gonna deteriorate and fail. When it does fail, your expansion tank then fills up with water. So now you have no means of expansion in your closed loop. So what happens then is your TMP valve, your relief valve, is going to start to drip.
Right. As you start to build pressure.
Right.
We're basically trying to accommodate for that thermal expansion.
Correct.
Right. With that expansion tank, that bladder, that membrane, essentially is compressing as we build thermal as the water expands due to heating up, it's going to push down on that bladder so that we don't build system pressure. As soon as that bladder is compromised, we don't have anywhere to go. The water is going to continue to expand, and we get that blow off.
Yeah, Brent and I were talking about these war stories the other day of replacing these expansion tanks, and you're going. Typically they screw into the bottom of the air eliminator. You unscrew them. It's a little half-inch threaded fitting, typically, if I recall. But once you unthread these things and take them out, they're now full of water. And you're going from something that weighs nothing. And I've actually smashed a toolbox. The first time I did, I wasn't expecting it. And I actually was telling Brent, I had a customer who was wanting me to diagnose this over the phone. I go, well, tap the expansion tank. Use your wetting ring. Does it sound hollow or is it a thud? Because it sounds, well, you need a new tank. So he decided, he didn't want to pay me to go out and do it. He did it himself. This isn't funny, but it's funny. He unscrewed it himself, and the thing just, boom, it broke his foot.
Oh, yeah.
Yeah.
And
They're heavy.
And he goes, you should have told me. I said, no, you should have paid me. This is why you pay people to do these things. You don't know how to do
it adds up 8.3 pounds per gallon.
Yeah,
So
right.
you get a 3-4 gallon expansion tank, do the math, it's going to get real heavy real fast.
Yeah, but it's that whatever that weight is, it's instant. It's because once that thing is not being held by that thread, it's instant.
Yeah,
And it's like
once that final
you're not
thread
waiting
is
for
free.
it.
Yeah, it'll drop.
So you mentioned TNP. It's temperature and pressure relief valve. So why do we need a relief valve?
Well, you need to protect the weakest part of your system. right? So all components in your system they're going to fail eventually at some temperature or pressure. And the purpose of this relief valve is if your temperature and your pressure exceeds a certain point, you want this to leak first. All right. You don't want to turn your closed loop into a pressure vessel,
Right.
where any part of it could rupture and burst. So when you can control that, it makes it more noticeable. So hence your T&P, usually off of your boiler or some kind of component in your hydronic system, you bring that to a conspicuous location where you can see a drip. If it's on the floor, you see a drip, you have something going on. So by code, I think it's about maybe 6 inches above the floor. You don't want this to be dripping on, you don't want this to be open-ended 3 or 4 feet above the floor where it could drip on somebody because the water is going to be hot.
Right.
So it's going to be brought down to the floor level, and then hopefully somebody notices it.
Yeah. Yep.
Hopefully.
Yeah. I mean, the big thing is controlling, right? So knowing that the potential for component failure could result in building pressure inside that system, we want to be able to give it somewhere to go. If we don't, it's going to burst either way, right? It's going to relieve that water somehow.
Yep.
At some point, some component's going to fail and we're going to relieve the water. Well, let's set something up that at a certain pressure will intentionally relieve that water so that we can protect, the building, the space, whatever we're servicing. So
Yeah, and they are, you had mentioned, they are designed to reseat themselves, but like you were saying, if you have a loop that hasn't been touched in years, you're going to have a lot of deposits that are on that. And that's the thing, when you're working closed loop hydronics and your temperature increases, you've got all these all these minerals that will come out of solution as the water is heated. And when it comes out of solution, it's going to go somewhere and it's going to collect on that T&P valve. It's going to open and it's not going to reseat itself and it's just going to keep dripping.
Yeah.
So, that's why when your expansion tank fails, you see a plumber or mechanical guy contractor replace that T&P.
Yep.
And the next item I have here on my notes is a backflow preventer. So when do we need a backflow preventer, and what does it do?
So a backflow preventer, is a way to separate your closed loop from your potable water, right? So you need it by code. What you don't want to have happen, if you have a potable water source piped to your closed loop for a system fill, then you're treating this closed loop with inhibitors, or you have anything else in there for water treatment. You don't want that closed loop going back into your domestic water loop and then somebody drinking it.
Yeah.
So it's a means of protection. So if you do have an issue where there's a pressure differential or any kind of failure, you will see water dripping from your backflow preventer it's a means of protection, right? So it's going to drip out of the bottom of the backflow before it goes into that potable loop. So you're protecting anybody that's drinking that water from whatever could be residing in that system.
Yeah. And with the case of our HVRF, we have a refrigerant to water plate heat exchanger.
Right.
So if there were to be a failure of that plate heat exchanger, we start to build pressure on the system side, and we don't want that getting into the potable side. If that refrigerant were to leak into the water side,
right.
We don't want that making it back into the potable side. So that's what that backflow preventer is. And essentially it's a check valve, right? It allows flow in one direction, not the other.
Right. And the way it was explained to me when I went to school is the water that you open the faucet, the water that comes in that you can drink out of the kitchen sink, that's the same water that's feeding a fire hydrant.
Yep.
So the fire department, your neighbor's house, God forbid, catches fire. The fire department comes up, they hook up a hose and they hook up a pump to suck that water out of the fire hydrant. So now, if you don't have a backflow preventer in there, they could theoretically suck the water out of your boiler or out of that loop that's been there, that water that's been there for years and years. And if it's treated with anything, that's now back in the public drinking water supply. So that's the important reason. And that's code, and it must be code in the whole country, everywhere. Now, if I have something that's not a city water source, then it's probably still required by code, but then it's the reason why it's required is different.
Yeah. So next we'll talk about is we covered backflow preventers, strainers. So the hybrid VRF has a couple strainers in it, and the basic function, right, is just to try to catch any debris in that water flow, protect our components like our pump, any of our heat exchangers. If when we're doing installs, just like when you're doing a traditional VRF installs, there's a potential for things like copper shavings or debris to get inside that piping. Well, we want to avoid that with these strainers on the water side. And the first time that I started up our hybrid VRF system, we went through that debris removal process. When we pulled the strainer, there was Teflon tape, which you need the Teflon tape. You need to use it But if you use too much, you wrap it a bunch of times around the threads, and it starts to make its way inside that pipe. We don't want that getting into the pump or into that plate heat exchanger. So this is just a safety means to try to catch debris before it gets to any important components.
Yeah.
And then the one thing that's new to me, I've never really seen this, is the system fill for the HVRF. That's a little different for me. So for me, when I've seen a boiler, we got the backflow preventer, it's supplied with city water. If there's a minor leak or some evaporation, I mean, theoretically, the same water is going to be in that boiler forever. But because there is evaporation and minor little leaks, the system would fill its own water. If it needed a few drops of water, those few drops come in. But this system fill is a little different. Can you kind of walk us through that?
Yeah, so one of the components we're really endorsing on the QHV and the HVRF is the shot feeder. And that is a defined reservoir where it could be 2 gallons, could be 4 gallons, where you have a finite supply of water or glycol, depending on the medium, that you can fill your system up with. Okay, it's not meant for initial fill. Initial fill you want to do manually with a 55-gallon drum or what have you. And the glycol feeder or the shot feeder is used to kind of trim those losses over time as the system purges air from it, or no closed loop is perfect. You're going to have some minor leaking from seals and what have you. So I like it because if you do have a rupture in a system, like I said, you have a finite amount of water that can be introduced to that system. Whereas if you have a hard pipe connection with a pressure reducing valve, it's just going to go.
Yeah, it's maintaining that pressure.
It's dumb. It's just saying, all right, 12 to 15 pounds of pressure. All right, I'm just going to do that, and you can keep feeding it. And I'll never forget. I was at a job site years ago, and it was in the basement of a hotel, old steam system, and they had a relief valve that had gone, and the system was just making up. And I think there was probably a 3 or 4 inch indent in the concrete slab of just underneath the team, just because it just kept on dripping. Making up, and it was just going down the sanitary line, and it was going. Like it wasn't like a small steady drip; it was going.
Really.
And we went down there, and the facility manager was like, "Oh yeah, look at that."
Yeah.
Like,
so that's interesting.
Yeah. Oh, I'll have to get on that. But yeah, the shot feeder is good because, if something were to happen, you're not going to flood your system. Right. If you're in a finished space, you'll have water leak out, and then it's going to stop. There's usually a set of dry contacts on your shot feeder that you can interlock with a BMS or send some kind of an alarm like, hey, we have a loss in pressure here. Somebody needs to come and look at it. So it's really something we're pushing for, just to protect the customer from any more substantial damage that might happen.
Yeah.
That's actually a good idea because, again, my motto is anything with water, it's not a matter of if it leaks, it's a matter of when. I assume everything with water and it's going to leak. I've got a dishwasher, I assume it's going to leak. I've got a shower, I assume it's going to leak. The kitchen, it's going to leak eventually. Maybe not in my lifetime, but it will leak eventually. So I think that's a great thing because, as you said, if there's a leak, you lose what's in there. 2 or 3 gallons is a lot better than 2,000 or 3,000 gallons or even hundreds. So
yeah.
That's good.
And like you were saying with the, a system feeder, shop feeder, if you do have those contacts, like a normally closed contact that you can utilize, with our hybrid VRF, we have a jumper just like we do a CN4F in all of our indoor units. In theory, we can use that. If it opens up, it's at least going to throw an error code on the system telling us it's a drain fault. And realistically, we've got a leak somewhere. So at least it gives us something to alert. Even if we weren't using like a third-party BMS, we can still at least get an error code if we were to have an issue with the water volume left in that system feeder.
Right.
Yeah, good point. All right, you mentioned water quality a few minutes ago. Let's come back to that because I really want to make sure that our listeners understand the importance of the water quality. And we were talking about it offline. The chances, if you look at the guidelines for the water quality, the chances of any place in this country actually meeting those standards is pretty slim.
Right.
So what do we need to do with the water?
So water itself it's tricky. There is a defined or an acceptable amount of particulates that are allowed in water. And some of these particulates are not very good. You can have things like chlorine, asbestos from old piping, copper, arsenic. Like a lot of this is a result from, you're looking at things like byproducts of wastewater treatment plants, disinfecting the water, factory discharging, herbicides, pesticides, all this stuff gets into water. I think one of the biggest things we have now is PFAS. You know, that's been a pretty hot topic just because the current administration is kind of ratcheting down on the amount of acceptable PFAS, or it's a man-made product that's used as a water repellent that's in a system. It's not the human body can't process it.
Right. That's what they call those forever plastics, right?
Exactly.
Yeah.
Exactly. So water isn't good. I mean, it's great, but when you drill down to it for a mechanical system, it's you have to take care of it. You have to treat it. And water is going to have minerals in it. It's going to have calcium. It's going to have magnesium. Like what I was saying, when you heat that up, it will precipitate. It will come out of solution, and it will collect somewhere. Mm-hmm. So with our systems, with our closed loops, we heavily encourage using some kind of a demineralized solution to try to extract all of those components out of the water and take care of that system.
Yep.
Sure, it'll work if you don't treat the water, you introduce it, it'll work until it doesn't. Mm-hmm. Right? So the more you can treat that water before it's introduced, the better off you're going to be, and you're going to protect your customer.
Getting back to hot water heaters, in everybody's home, there's a hot water heater, unless you've got a tankless. But if you've got a hot water tank, a 30, 40, or 50-gallon hot water tank in your house, they put a special rod in there that attracts these minerals, because those minerals are going to attack something and eat away at something. So there's that special rod. I call it the sacrificial lamb, because that rod is going to attract all those minerals, and it's going to eat away at that. And if you ever replace one of these, when you put it in, it's this long white rod, maybe a half-inch, three-quarter-inch thick white rod. And you go there 5 years later and you're going to replace this and take it out, it's nothing. There's nothing left to it. If it wasn't for that rod there, those minerals are going to be attacking the tank itself, and it's not going to last.
Yep.
And they get the tanks. I remember talking to my plumber about this. And we've got the 5-year tank and the 10-year tank. You know what the only difference was? There's 2 rods in the 10-year tank instead of 1 rod.
Yeah. And even then, with the anode rods in there, if you replace it and you cut that thing open, you'll still see mineral buildup on the bottom of that tank.
Yeah, you got to flush that out.
It's just the nature of water.
Every spring I empty out my hot water heater. I use it to rinse off the snowblower. When I'm done, because all that salt is in the snow, and so I kill 2 birds with 1 stone. I'm draining it right from the bottom, Who cares if that gets on the snowblower? Just getting all that salt off. And what about glycol?
So glycol, it's fantastic because, if you have a flooded system and that system is outside, you can utilize glycol to make sure, if there's a power outage or anything goes wrong, you're not going to freeze your system. With our QAHV system, we encourage glycol on that primary loop. You have a flooded system between your heat pump, your outdoor unit, and your heat exchanger. So if there ever is a power outage, then you're covered. Your glycol, it depends on the concentration of glycol. We allow up to 30% propylene glycol. So you've got a freeze protection down to about 10 degrees and a burst protection at around minus 10. Same thing on the geothermal system, the PQRY. So glycol on that, you can enable the unit to function as a geothermal heat pump, where you're instead of using a closed loop with water temperatures 80 degrees for old fashioned water source heat pumps, you can enable that for geothermal. You can go down as low as 23 degrees. So obviously water doesn't go down to 23 degrees, but glycol can.
Right. So just for folks listening, when we talk about glycol, we're talking about essentially antifreeze. It lowers the freezing point of the water or liquid inside that system.
Correct.
So we used to have to do that with just residential boilers. People would shut down their systems in the winter. I worked out near Vermont, and there was a lot of temporary homes. They weren't there in the winter time, things like that. And we would antifreeze their boiler instead of draining it down, because that's how they wanted to do it. They'd run it at a really low temperature. They'd keep the house at maybe 45 degrees while they were away. But in order to just protect the boiler, they would have us antifreeze or glycol that system.
It's good insurance, because if you've ever had a pipe burst, by the way, every customer of mine who ever had a pipe burst in February, it was all for the same reason. They went to Hawaii. Yeah. I'm not joking. Everybody who went to Hawaii in February came back to frozen pipes that burst. They had one lady, I walked in there, and I got the heat going. She had, she didn't have hydronic. It was air. And it quit while she was gone. And I'm like, it was like 18 degrees in the house. I go, listen, I'm going to tell you something. I'm going to get this heat going, but you're going to have a water leak somewhere. Somewhere one of your pipes is burst. It could be inside a wall.
Yep.
And she goes, what do I do? And I showed her where the shutoff was. Right. And I didn't check it. I should have checked it because it was frozen.
Yeah.
Right.
Yeah.
And she ended up calling the fire department like a half hour after I left.
Oh, goodness.
Because it, but anyway, don't go to Hawaii in February without getting somebody.
That actually reminds me of a story I had. This is actually the exact opposite problem. Folks went away to Hawaii, and I had gone there and done some work on their home. And when I was testing the system, I pulled down a manual lever on a zone valve, and it was one of the ones where when you pull down the manual lever, closes your end switch.
Yeah.
Well, I left it down.
And nice and warm in the house.
When I got there, their thermostat, when they got home, just said high. They had candlesticks that were bent over, and their fridge was hot.
Yeah, we've all been there. I've left my jumper wires on before. And,
Yep.
gotta go back. Anyway, Chris, anything else we need to touch on as far as hydronics go that we haven't already discussed?
Yeah, I think the last thing with glycol, it's just like water. It's not a set it and forget it. It does break down over time. And when it breaks down, it becomes acidic. And when it becomes acidic, it's not good.
Yeah.
Right? Because you're going to get corrosion. So, glycol, you still need to maintain a treatment procedure on that, just like water. All right. And with glycol, usually you're cut off for concentration. You don't want to go any less than 25% because I don't know if you've experienced any pot feeders or what have you in the field when you have low concentrations of glycol. It's a bacterial breeding ground. So it's not pleasant. So usually, if you're at that 30% range, 40% range, you're good. Anything lower than that, it's gonna cause microbial growth in your system. So just like water, you need some kind of a treatment procedure for glycol.
Yeah. What I usually found was if it was a glycol system and it was not maintained, was a lot of fittings. You'd start to see green show up around the fittings,
Yeah,
corrosion,
that's your corrosion.
because of the acidity. And you'd walk up, especially where I used to work, you'd walk up to a boiler, and if every single copper 90 on that system had that corrosion, you're like, oh yeah, this thing probably has antifreeze in it.
Yeah.
Drain a little water, you can smell it, and you're like, oh yeah, it does.
Yep.
And Chris, correct me if I'm wrong, but I think glycol, the molecules are smaller than water molecules, so they'll leak easier than water will.
Right.
Well, I think that's it. Chris, thank you very much for joining us, and thank you for the information.
Very helpful.
My pleasure.
Yeah,
Thank you.
I learned something too here.
Which is what you're not going to use protein powder for.
Yeah, no, that was disgusting. Seriously. So, we're talking about olive oil earlier, and I saw this on 60 Minutes years ago. I avoid Italian olive oil. As much as I love it, I avoid it because and don't have your family come after me, but the mob in Italy, it runs it, so it's not even really olive oil when they've taken this. It's actually sunflower oil and a bunch of other things, but it's not real olive oil anymore. So I've actually had to get Portuguese olive oil is good. Greek olive oil used to be good, but I think the mob moved in to that as well. So I've actually been having good luck with some California.
Paul, you'll notice Chris is being really quiet right now.
I know.
You might want to stop talking
I know.
about the mob.
I'm going to go out to my car, and there's going to be somebody out there with hey, get in the trunk.
What's that red dot on the back of you, Paul? I don't know.
No, but just think about olive oil. There's my favorite olive oil. I was with the Mid-Atlantic team. Jeff France and I were at a restaurant in Indianapolis, and of Seasons olive oil. It was a bottle of Seasons. It was so good. I took a picture of it, and I ordered it through the mail. I don't know if it's California or where it is, but it's some wicked good olive oil.
I'll have to look into that.
Yeah. And by the way, thank your wife. You mentioned you're afraid of her. I don't blame you. I would be too. She probably doesn't listen to the show.
She does. That's why. So for all the listeners out there, I brought in a super special recipe of pumpkin snickerdoodle cookies for the team here.
What's your wife's name?
Nicole.
Nicole, these are some of the best cookies I've ever had. Can you ship one box of these every month to the office? We'd appreciate that. These were delicious.
Well, we'll have to get them over to Juan too, because that's why I brought these in, because when you invited me onto the podcast, I came home and I was like, guys, my kids, Rocco, Sienna, it's like, guys, I've summited Mount Everest here. I was invited to the podcast. I am so excited. And they're like, Dad, what's a pod's nest? And I'm like, I'm all right. So I take out my phone and I start playing the last episode of the Menace Tech Show. And it's Juan, in the beginning, he's talking about, I think it was like he wanted to cover himself with pecan pie or something like that. He was just going down a path of destruction on that.
Yeah.
And we're listening to it. And my wife's like, this is like a mechanical podcast. I'm like, it's a long story. They like food a lot. She's like, all right, well, since you're talking about desserts, I'm going to make my famous cookies. And I'm like, they will not go to waste.
No, they won't. I'll tell you
Not
what.
at all.
I will take the responsibility of getting these to Juan.
Yeah. Just
Sure,
leave them with me.
I'm sure they'll all get there too.
Yeah, you know, it's funny, Chris, is that week I had made an apple crisp for the office, which is how we got on the topic. I had to make a second one by the end of the week before he left because that's how quickly it went.
Yeah,
So those
I believe
cookies probably won't make it through, Wednesday?
I'm thinking they won't make it through 3 o'clock. Yeah, but thanks, Nicole. They were delicious. Really.
Yeah, thank you.
Hey, thanks again, Chris.
Thank you guys.
Take care.
Appreciate
Bye,
it.
everyone.
We'll see ya.